Okay, what we have here is the beginning of chapter 6, where we're going to be talking about exponents and radicals and making a connection between the two. So looking at today's objective, we have a couple main points. Understand the two different forms. How can we show a radical, i.e. a square root of some sort, as an exponent using rational numbers? And the second objective is finding the nth root versus evaluating. And we're going to talk about the difference between those vocabularies. Okay. So let's first talk about these three examples up here. When we talk about the square root of 4, and notice there's no number right here. So what number goes there? It's like the 1 in front of x. If I say, x plus 4, and I say, what's the leading coefficient? You could say, well, there's an imaginary 1 in front of the x. The same thing goes with radicals. If there's no number in front of the radical, it's understood to be 2. That's why we call it a square root. Square being, two sides there, the two different dimensions. Notice the other ones have a number, and we call that number an index. And it tells you the number of roots for that number. So when we say, what's the square root of 4? Well, we could really say, what's the square root of 4? A number times itself that equals 4. Well, there's two factors that make up 4, 2 and 2. So we'd say the square root of 4 is simply 2. So right now, notice I am evaluating. Okay? I'm just finding the answers if I plugged it into the calculator. When we talk about the cube root of 27, we're saying, okay, what number times itself 3 times equals 27? Well, that's 3 times 3 times 3. Notice the index matches how many repeated items in that number. So we'd say the cube root of 27 is 3. Okay? We'll study this in last chapter 2 where we talked about finding the cubic root of something. So now we're saying the fourth root. The index could be any number. So what number times itself 4 times is equal to 16? Well, that's 2, as we can see right here. Okay. So the index is looking for how many times that value is multiplied to get that value. Now, notice in all these examples I have positive answers. So that's evaluating. If you plug into the calculator, what would you get? Okay. Well, we want to focus on two things. How do we show this as a radical, and how do we show it as an exponent? So what we have here is this. Let's look over here at a to the n power. Well, we can take a look at the n, and let's say that we show that as a fraction. So if we had a normal exponent, you have a to the n power. Now again, we could put it over 1, and nothing's changed. But let's say this 1 was something different. And let's put it over m. Okay. The m is the index, and that is the root of the number. So obviously the root makes things smaller. We say like the square root of 4 becomes 2, and the number on top is going to make things bigger. Okay, and we're going to show what it is. So basically what we have is every radical or root problem can be shown with rational numbers in a fractional exponent form. And it's nice because you want to be able to work both ways so you can solve number of problems in one or either form. So let's kind of do a little more talking here right now. Let's go ahead and show some of these examples. How can I show the square root of 4 as a fractional exponent? Well, 4 is your base, and the index goes on the bottom, and being that it's 4 to the first power, we show it like that. So 4 to the 1/2 power is the same thing as saying the square root of 4. So let's look at 27. 27 is the base, and it's raised to the first power. There's no other 27s there. And the index is 3, so I'm going to put that on the bottom. The fourth root of 16, 16 is your base, and there's only 1/16 raised to the first power, and we have the fourth root, so the 4 is the index. Let me show you one other thing, kind of tying this together. I could rewrite this as the square root of 2 squared. And notice I could show this as 2 squared over index of 2. And what happens here is this. 2 divided by 2 cancels each other out, and you get 2 as the final answer. And that's what our answer is. So we got to answer 3. That's the same thing as saying the cubic root of 3 cubed, or the cubic root of 3 cubed as a fraction. Let's show it this way now. 3 raised to the 3rd power, right there, divided by the index. 3 raised to the 3/3, well, 3 divided by 3 is 1, and you get 3 all by itself. Okay, so we're just showing different ways to show these numbers. Okay, and obviously here, this could be written as the 4th root of 2 raised to the 4th power. Notice the 4 2's. Okay, so how else can we show that? 2 raised to the 4th power divided by index of 4. Well, 4 divided by 4 is 1, and 2 is your final answer, and that's what we got. Okay, so the key to pick up here is not as much the green. Don't worry about if you didn't get all that. We'll talk about that a little more in class. But how to convert from the red to the blue form. How to go from a radical to a rational exponent. Now we have this little thing down here about roots are like solving all possible real answers. So that's what we're going to work on next. Notice in this example, we're talking about evaluating. So on this slide here, we're talking about what's the difference between evaluating and finding the roots, okay? This is the difference of saying, okay, what is the square root of 4? And a lot of people say 2. You evaluate it. You plug it into a calculator, what do you get? Now, if I say x squared is equal to 4, and I say solve, you simply take the square root, and we know that x is equal to plus or minus 2. All possible answers, okay? All possible scenarios. And this is the same thing as talking about roots. Roots is another way for solutions. The two words can be interchanged. Whereas over here, we're talking about evaluating, and you only deal with the principal root it's talking about. The one that, if it's positive, it's going to stay positive. So this is talking about the principal root over here. But roots in general is like solving all possible answers. So we want to get those two words figured out. So let's think about it. If we have even index, okay, and these have to do with index, we want to think, okay, what is, the 4th root of 64, okay? And now we're talking about roots. So what I would do is say, write it as a different expression, okay? If the instructions were saying, let me erase this here. Okay, what is the 4th root of 16? We see that root, we're thinking solutions, okay? And that is what we're looking at. So we'd say, okay, what number times itself 4 times is equal to 16? Well, you could say 2 is the answer, or you could say -2. Because -2 times itself 4 times is also going to be 64. So -2, to show it like this, -2 raised to the 4th power is going to equal 16. So -2 is a root, okay? So you have to be careful when you see that word root. You're really talking about solutions here. So notice, whenever you have an even, you can get this positive answer by either getting positive answers or negative answers. Every even is positive answers, and you're going to get 2 sets. So I'm going to put a little note here, 2 sets. Whereas odds, I say, okay, what is the cube root of 27? And you're going to say, okay, what number times itself 3 times equals 27? The only answer is 3. Because notice if I say, okay, what's the cube root of -27? You're going to say, what number times itself? And then you're thinking, well, we can't have a negative inside a square root. This is not a square root. This is a cubic root. This is an index. So what number times itself is equal to that? Well, let's take a look here. The cubic root of -3 times -3 times -3. Well, that's going to be -27. So the cubic root of -27 is simply -3. The sign for odd ones is the same. Whereas here we had an odd, positive, positive, same. So in conclusion here, if you have an even index, you will always have 2 roots, a positive and a negative. If you have an odd index, you're only going to have one root, and it's going to match the sign. Okay, so we'll see those in a couple more examples here. All right, so on this slide here, we're talking about changing forms. Okay, so this is kind of like tying the last two slides together, and we'll see some solving problems. If I see 16 to the 3/2 power, again, this is the bigger number, the exponent, and down here is the index. So I'm going to start with my base of 16, put it inside a radical. The index goes out front, so we're talking the square root here. And the big number, the power, I'll do it in a different color here, not the power, but the exponent on top, the numerator, goes down here. And we say 16 cubed. Now notice I put the 3 inside the radical. Okay. And like I said, you could actually figure out what 16 cubed is here. So let me pull up the calculator. Right here. Just turn it on. I use the keypad here. So if we say, okay, 16 cubed is equal to 4,096, and I say, okay, what's the square root of that? We can get an answer of 64. Okay. Now, there's a couple ways to look at this problem. The square root of 4,096, and again, this is going to equal to 64. Now, let's look at it another way. I'm going to take the square root of 16 first. So, the square root of 16 first, and then I'm going to raise the whole thing to the third power. And I show you that these two things are the same. What's the square root of 16? 4. What's 4 raised to the third power? 64. And the two answers are the same. Because with exponents, it really doesn't matter the order you do things, just as long as you follow the rules. Okay? So let's take a look here at the next example. Move the calculator over to this side. And we have, okay, 32 raised to the -3/5. So the very first thing I see is a negative exponent. So I'm going to rewrite this as 1 over 32 to the +3/5. And I'll say, okay, I'm going to write this as a radical. 1 over the radical of 32 raised to the 5th power. I'm sorry, raised to the 3rd power. Got those backwards because that's the numerator on top. And the denominator, the index, goes right here. So, okay, what is the 5th root of 32? Well, the 5th root of 32 is 2. 2 times itself 5 times is 32. So now we really have 1 over 2 raised to the 3rd power, which is going to be 1/8. Okay. What I always like to do when I these problems is I like to look at the index first. I like to make this number smaller. Why take 32 and triple it, and 32 times 32 times 32, and then have to take the 5th root of that? You could do that, but you're just making the numbers bigger. Try to make the numbers smaller by looking at the index first, and then raising it to a power at the end. So in the end, we want to get 1/8. Let's take a look here at the last two examples down here. Okay. So we have the cubic root of, the square root of 4 raised to the 3rd power. So here we want to convert it to an exponent form. So I'm going to start with my base, 4, and I'm going to raise it to a fraction. Notice my index, imaginary 2, so I'm going to put a 2 on the denominator and a 3 in the numerator. And right there is what we have. Okay. Now, there's a couple different ways you can look at it. Say, all right, what is the square root of 4? Okay, well, the square root of 4, if I look at it this way, raised to the 3rd power, well, the square root of 4 we found to be 2. And 2 raised to the 3rd power is equal to 8. Okay? And we can see the same thing here, too. We can say, okay, I'm going to work backwards in this one. 4 raised to the 3rd power is 64. And then if we do the 1/2 on the outside, because 3 times 1/2 is 3/2, and say, okay, what's the square root of 64? Well, we're going to say, well, that's easy. That's going to be 8. Okay? So notice we're going to get the same answers. Okay? So you want to be able to work in both forms and start to make those connections there. Now, how do I write this as a rational exponent? I'm going to start with the base of 2. Start with a fraction. The index goes in the bottom. The exponent on the inside goes in the numerator. And again, I really can't take the cubic root of 2. That's too hard. So I'm going to make 2 to the raised to the 5th power, which is simply going to be 32. You know, if I look at it up here, 2 raised to the 5th power is 32, and then the cube root of that, can't really simplify it anymore. Okay, so you could show it as this, could show it as this, and as a rational exponent, you could show it like that. Okay. The key here is to go from one form to the other, from radical to exponent and back and forth. All right, the real nth root of a. So when we see these directions, we're saying find the root, find the solutions. So n is your index. 32 is the base, or the number inside the radical. So the 5 in the right spot here. What is the 5th root of 32? Well, again, this is odd. So we only have one sign. It's going to match. So positive, and 2 is going to be answer. 2 times itself, 5 times equal to 32. Now, same thing over here. Here we have another odd one. The 3rd root, 3 index, of negative 27. Now again, being that it's odd, we're going to keep the same sign and say what number times itself is equal to 27? 3. And being that it's negative, the negative 3 times itself 3 times will equal negative 27. Okay, so that's what we're looking for in those problems. Now notice down here where we talk about the 6th root of 64, we're saying, okay, what number times itself 6 times equals 64? Well, you're going to say that's easy. That's 2. But notice that it's even. So then we're going to say, all right, we need both roots, positive and negative. Because negative 2 times itself 6 times is equal to 64. All right, we're going to look at 625, and we're going to say, all right, the 4th root of 625, it is even. So right away, I'm going to put my plus minus in. Now again, I don't know what the 4th root of 625 is, so I want to pull out my calculator. So I'm going to show you on your calculator, where do we see this answer? Well, turn on n. I'm going to start with 4th root, and I'm going to hit then the math key and scroll on down to x, and then you see the radical sign, option number 5. So that is the index key. And I pull it up, and you're basically telling the calculator, find the 4th root of x. Now, some of you guys have the TI-84 or so forth, and that little 4 might show up in the index position. That's fine. And then from here, you just type in 625, and you're telling the calculator, find the 4th root of 625, hit enter, and we get 5. Now, again, your calculator is evaluating. But here we're solving, we're finding the root, so I'm going to put it as plus and minus 5. So here we're talking about roots. Okay? So that's what we're looking for in that example. Okay, now roots are like solving. Okay, so let's take a look at this here. I'm going to solve this 2 different ways. We can say, all right, first thing we got to do is get rid of that 4. So x to the 5th power is equal to 32. And I say, okay, how do we get rid of something to the 5th power? Well, you take the 5th root of it, just like taking the square root of something squared. So if you take the 5th root of one side, you do it to the other side. It is an even root, so an odd root, so you're going to have only one root that's the same sign. So we're going to have a positive, and the 5th root of something raised to the 5th power, they cancel each other out. And you say, okay, the answer over here is going to be 2. 2 raised to the 5th power is 32. Notice it's only one answer, positive. Now, looking over here, we're going to say, okay, x minus 3 raised to the 4th power. How do I get rid of this? How do we get rid of that exponent? Take the 4th root of it. Do it to both sides. Now, being that it's the 4th root, we want to take both positive and negative because it's an even index. So then this 4 and the radical cancel each other out, and you're left with x minus 3 is equal to plus or minus the 4th root of 21. We can't simplify that anymore. Okay? It's going to be an ugly, irrational number. So how do we solve for x? You're going to move the negative 3 to the other side as a positive 3. And there we go. 3 plus or minus the 4th root of 21. Now I'm going to show you another way to solve these problems using exponents. I'm going to write the same problem down. 4 to the 1/5. In fact, I'm going to pick up at the second step right here where we have x to the 5th power is equal to 32. Now, as exponents, watch this. Raise it to the 1/5 power. 5 is now in the denominator, and that's your index. What's 5 times 1/5? Boom, cancel each other out. So if you raise one part to the 1/5, raise the other part to the 1/5, and the 1/5 exponent of 32 is 2. Again, you can type that into your calculator. So let me show you on the calculator how we type that in. So again, pull this over like that. I can type in 32. I'm going to raise it to a fractional exponent. So use parentheses, 1 divided by 5, close parentheses, enter, and your answer is 2. And again, we're dealing with an odd, so the sign's going to follow. Let's take a look here at this example here. We have x minus 3 raised to the 4th power is equal to 21. How do I get care of that 4? I'm going to raise the whole thing to the 1/4 power. The reciprocal, knock it out. So 1/4 times 4 cancels each other out. And you're left with x minus 3 is equal to 21 raised to the 1/4 power. Okay? And again, if you want to show it that way, x is equal to 3 plus or minus. Now again, don't forget that plus minus because it's an even root, 21 raised to the 1/4 power. Okay? And again, that's just showing it as an exponential form. Here we have it as a radical form. Okay? So that is the difference between the two. What I want you to do, I know this was a lot of material. Again, I kind of threw a lot of stuff at you. We'll digest this stuff on our next lesson. Really what I want you to start on here is, let's just do these 5 problems here in yellow, just to get used to how to write them in different form, and then we'll work on solving and taking it from there in class our next period.